I've always viewed science as a series of questions, and that the questions are very fundamental. As you answer, new questions arise. Questioning is the basic process of science. It's the basic process of inquiry, and I rather think it's the basic process of life, if you will. We question, we proceed into so many unknowns, so many uncertainties, and it's our questions that allow us to go on that journey. It's not our answers. My mentor in medical school at New York University was Lewis Thomas, who was a very unusual professor of medicine in that he was a poet and philosopher and writer. In the introduction to the textbook of medicine, the main textbook, he wrote in the early 1980s that he thought that the greatest single achievement in science, in this most scientifically productive of centuries, was the recognition of our ignorance, of how little we know, not how much we know, and how much we have to learn and discover. And then he said at the end, sort of in a whimsical manner, I wish there was some medical school in this country that taught a course on medical ignorance, and then somebody that wrote a textbook on it. And we decided in the mid-1980s to take him up on the suggestion, since we thought that medical education was ailing in just this particular characteristic, to focus on what we don't know, since that is most of what medicine is about. We operate in a terrain of relative ignorance, trying to do the best we can with what we know, with the tools we have, but always searching for better answers for every kind of problem that was coming up, whether it be AIDS, heart disease, cancers, etc. We all know that there's got to be much better out there in terms of understanding the disease process, how to diagnose it and evaluate it, and how to treat it. The concept of ignorance and questioning that we've developed has been very understandable to adolescents, teenagers, to whom it's a foreign concept, and that they've really kind of embraced it and enjoyed working in that terrain of discovery. And they've experienced discovery. They haven't been going to labs and worked as technicians and sort of mindless robots, but they've understood the questions that the research is directed at. To take a high school student out of a disadvantaged environment where they've really done nothing but maybe a little cookbook science, and to have them come into the real world, real professional world, to act as professionals, and to master, in a sense, what's going on in the lab, and then to be contributors to that, and to be valued by the people they're working with. All those are successes, and have to make you proud of that you're involved in it.
I was in it around 1988, the second year of the program, and back then it was a small program where they accepted around 5 students, and it was more supposed to be a minority program where you would have some disadvantaged students. And it was a lot of fun back then. I got to do research in breast cancer, actually, with somebody who's now faculty here. So it was my first exposure to what it's like to be a medical student and medicine in general. It introduced me to research, which is sort of a different world than just regular medicine. Because with medicine in general, you just see patients all the day. At least that was my concept, that you see patients and only think about medicine. Well, I think it's a wonderful opportunity because I don't think I would have come to medical school if I hadn't done the program. I probably would have settled for being a computer programmer. But also when I see the students, they learn to question and think about things a lot better than they had before. They get presented with data, but they don't necessarily think about it. They just memorize it and spit it back when you ask them what it was again. So now they're starting to think about what they're learning. And also it's a good opportunity for the students to get used to being around people who they consider knowing, to be more knowledgeable. Before I came to the program, everything was, if the teacher said it, it was true, it was law, there was no other opinion. So I learned that there were other opinions, and in fact our teachers didn't know everything, and that truth actually does change as we learn more. Ignorance is just something we don't know. it's not necessarily that we don't know it because we're stupid, it's just because we don't know to ask. So I think that the more I learn, the more ignorance I have, because just learning something new unmasks more things that you don't know. So it's something good because it'll keep you going.
There are many components to the curriculum on medical ignorance, and it's evolving. And we take suggestions from the students and the teachers because often they see holes that we might not otherwise see. The central experience of the Summer Institute on Medical Ignorance is the full-time research activity, which takes place in all of the departments and components of the Health Sciences Center. So the student is doing full-time research either in a laboratory, for instance, studying the molecular basis of how blood vessels form, or working in a clinic where they're studying the effects of certain drugs in manic depression and psychiatry, or working in the field looking at environmental exposures. So they could be working in a lot of different contexts, a lot of different mentors, a lot of different departments, but they're focusing on a set of questions that they come to realize as they're studying and how those questions are being addressed by the scientists. And then at the end of the summer, they present their work, usually a PowerPoint presentation, which for most of these students would have been thought unthinkable. And in a very short time, they tell us the questions they began with, what they did, what the science dealt with, and the questions they ended with. And this is very important that they end with questions. These are not the teachers asking questions, although they can certainly incorporate that as an important component. But it's getting at the students having their own curiosity, knowing enough to ask questions, wanting to know more to ask better questions, and then learning some of the tools to answer those questions, and getting the confidence that they can compete or they can accomplish a lot more than they ever thought they could accomplish. And participation is not just with the hands. Hands-on is part of participation in science, but it's brain-on, that is really engaged, really understanding what you're doing and being at the cutting edge, understanding what the Human Genome Project is, understanding what the stem cell controversy is, understanding the engineering of artificial heart, and understanding our limitations in taking care of patients. So they can understand what medicine is about, what health sciences are about, and what science is about. I mean, and this not only gives them opportunities for careers, gives them inspiration to get more education, but I think it ultimately can improve the health of the public as well.
Since the Summer Institute on Medical Ignorance began some 18 years ago, personal computers and the Internet have drastically changed both our social and cognitive environment. It's now realistic to believe that students from around the world can participate in a curriculum in medical ignorance using new tools being designed as part of the program. Those tools will allow students to simulate many of the Summer Institute's experiences. Part of the Summer Institute experience is to provoke students into thinking about the unknown. The Institute attracts many talented people with amazing abilities and areas of expertise. Yet, each participant is encouraged to think beyond their domains of expertise to what they don't know by constructing an island of ignorance. An island of ignorance is a logically organized collection of questions about a topic that interests the students. The island can take the form of a poster session, a live presentation, a diorama, or even a website, complete with 3D walkthroughs comparable to a science exploratorium. The island is a construct that expands as students learn more about how little is known regarding their topics. The questions that arise in an island of ignorance drive research, investigation, and deeper inquiry. Here's an example called Diabetica Island, created by high school science teacher Jorge Ramirez. He began with a pencil sketch on paper, scanned the sketch, and then developed and refined the concept using a graphics program. Scheduled for 2007, an Island of Ignorance construction kit is due to be made available to those schools participating in the medical ignorance curriculum. Another exciting tool being refined by the ignorance team encourages collaboration and brainstorming. These tools allow us to create ad hoc networks and relationships facilitating informal conversations between students and remote mentors. That same tool will be used to create a virtual clinical research center supporting research with young scientists and experts around the world. This virtual GCRC will vastly improve the reach of the handful of static GCRCs around the country. If the Ignorance team is ever going to be successful at encouraging new, young thinkers to enter science, the effort must start in schools. The team is developing a complete curriculum for teaching the value of ignorance and the excitement of questioning. Along with that curriculum comes a fascinating collaboration tool called the Questionator. The Questionator is software used in the classroom that's fun to use and exciting to see in action. Logging into the Questionator places the student into their private workspace where they can remain anonymous while they connect with classmates to conduct thought-provoking exercises. It currently supports 3 features: the Question Collector, the Pollster, and the Ignorance Log Generator. The Question Collector is used to encourage dialogue in the classroom by challenging students to anonymously submit questions to a learning facilitator or teacher. Issues of shyness or embarrassment are eliminated as ideas flow to a central display seen by the class. The second tool, the Pollster, provides an opportunity to challenge learners' assumptions and encourage critical thinking by asking students to vote on provocative issues. Votes are immediate. Teachers can encourage classroom discussion after an initial vote, then re-vote to see if opinions are changed or strengthened. As students participate in the Question Collector and interact with the Pollster, the stigma of ignorance disappears. Ignorance and coming up with difficult, challenging questions becomes fun. The questions students pose are stored in their private database where they can later retrieve them to use the third feature of the tool, the Ignorance Log Generator. Dr. Whitty likens ignorance logs to a journal-like history of questions asked about topics that interest students. Over time, if one looks closely, one sees a change in the quantity and quality of scientific questions. The logs become a reflection of the maturation each student undergoes as they learn that ignorance is embraced as the kindling of new knowledge. The search for answers becomes as natural as breathing. And that's the goal of the curriculum in medical ignorance, to help breathe new life into science with the joy of asking questions.